Cool. So, Chris is here all the way from Chicago, actually. We were really lucky. He came in town just for like the day.
Just today.
And I was like, hey, you should come give a talk about smoke and mirrors. It's cool at the meetup. And so he took the Caltrain down because I tried to get him. He had a ride and it fell through. And so
tried to get a different ride that fell through.
And so he took Caltrain down. And is anybody going back up to the city tonight?
Yeah, if you are, I need to go to the airport. Hi.
Worst case, we'll take you back to the train station. Or I'll get you an Uber.
Yeah.
I'll pay for it. So Chris is here all the way from Chicago. He does some really cool stuff with mobile and Ember. And one of the things that's important for him is obviously performance on mobile. And so he's done a lot of cool work lately, open source work on a project he calls Smoke and Mirrors. And so without further ado, Chris, run Spired. I'll give the floor to you. This is lightning talk, so you know.
Yeah. So I apologize for the crudity of this. I kind of found out I was doing this like 2 days ago. I was like, okay, yeah, I'll wing it. So I started building an HTML5 app, iOS first, in Ember about probably a year and a half ago. No, probably just a year ago. It was my third Ember app at the time. I built a couple of smaller ones since too. I felt like I had a pretty good idea of the challenge I was getting into building a mobile app with Ember, and I felt that choosing Ember was a good choice because that even where Ember's performance was bad, I could see it heading somewhere good. HTML bars had already kind of been revealed at that point, and I was like, well, given development length, given my knowledge of Ember, I think I can go in, I think I can do this, and we're just gonna iterate on the fly and figure things out if we can't. Well, we hit about Ember 1.7, 1.8, and we don't have HTML bars yet. We're going, this is really bad. We've already moved to Ember CLI. We've got Liquid Fire. We've gone through and optimized the hell out of everything in this app. We've got our run loop saying, all right, push everything you can do for data processing until after we even render and just return live data. We've got stuff running in web workers. We've got stuff GPU accelerated everywhere we could possibly can, and our transitions are still nothing near close to what we want. The app itself is pretty simple. It's a conversation app, but what you get with that is really long lists. And I knew going into it that Ember had this thing called list view, but list view didn't work for us because in a conversation, you have no guarantee about how big your message bubble is going to be. You get photos, you get all sorts of interesting media in there, and list view wasn't going to cut it. So I found this project called Ember Cloaking, which maybe you've bumped into. It's used by Discourse. Threw that in there, and we ran with it for a while. And that got us really far. But we hit this point where we said, all right, we really want to be able to control the scroll experience in a very minute, detailed way. A new conversation, you have a new conversation, you add a new message to that conversation, it should just insert to the existing DOM and scroll down to it. We shouldn't have to worry about the fact that the DOM might completely rebuild. We had a lot of unique challenges with this app, mostly because conversations aren't as stable a thing as you might think. They're not as stateful as we would have liked. And so that underlying data array would often get completely swapped out. And until I learned that that was what caused so many performance issues in Ember, that was probably our biggest stumbling block. So enter Smoke and Mirrors. Smoke and Mirrors is kind of the end result of a lot of different sub-optimizations that I started doing to Ember Cloaking and to our app. That started with the array layer. I said, okay, what can we do to prevent array swaps from hurting us that badly? And the answer to that was, well, why don't we throw in an array proxy? And that way, when we swap out the underlying array, we maintain a stable array. Well, that actually didn't help us that much because the items in the array weren't as stable as we would have liked either. So then we were like, well, what can I do to keep the items in the array pretty stable? Because they do have constant keys, but the data in them and their order and whatnot is changing a lot. So I started thinking about this problem and I realized, Ember is actually really fast as long as it's relying on bindings. Where it really chokes is when you force it to go rebuild all your views and rebuild all the DOM associated with those views. So I decided I would proxy the content of every item in our array. And that way, when the array got swapped out, instead of completely having a new array, that proxy would go through and say, all right, my new array, how does it match up in length to the old array? Oh, it's 5 items different, it's longer, add five proxies to this array, and continue proxying all the content. Oh, it's 5 items shorter, remove 5 proxies from this array. So the underlying array was very stable. The underlying objects being used to generate the views were very, very stable. But the data itself could be changed as much as you want. Demo today, this is running Glimmer. But what's really cool about this is that the Glimmer version of this, I've stripped out that array proxy entirely. The pre-Glimmer version and the post-Glimmer version are roughly the same performance. The pre-Glimmer version, where your big cost is that initial render. Since you're sending it through all these proxy layers, you have a slightly longer boot time. Not much, but it's noticeable. I found nice little UX ways around that. But post-Glimmer version, it's not. So this is Glimmer, as you may have come to realize and see, without any optimizations to it. Well, it has the key for the each, but other than that, this is the nested array, and it really doesn't do as well, I think, as we're hoping. This is running beta 2. There have been a lot of optimizations that are running on master. I wish this were running on master because I've run this against master and it's a lot faster. But this is beta 2. This is the same beta 2 if you use occlusion. So that was part 2 of this project. As I said, Ember cloaking, it's great, but where it chokes is it really doesn't handle scrollable divs. And so this is a scrollable div with div ends here. It pauses a little bit while you're actually scrolling, but the moment it finishes, you'll notice that your code fast paths, and it's a lot faster. The reason for this is actually very obvious. You have a svelte render. It's a lot less content to diff. It's a lot less content to even think about while it's rendering, because everything that's off screen here gets occluded in 2 different ways. I've come to realize that occlusion isn't a concept that a lot of web devs are familiar with. Basically, occlusion is anything that's not visible, you remove it. Some people call it occlusion culling, some people call it cloaking, some people just call it list view. But really, the real term for this is occlusion. I'm using occlusion here in 2 different ways. Basically, I say if you're just a little bit off screen, set visibility to hidden. Just that one thing, that one CSS tweak, gives you a huge performance boost. It keeps your layout the same size, so your layout's not affected, but anything within that item, you don't have to do any repaints to, you don't have to do any redraws to. So as it's going through and trying to do a re-render in the DOM, it's able to do that a lot faster. As it gets a little bit further down the screen, it says, remove the content of this item. So you have a placeholder item in place still, but everything inside that item is removed. It's at the point that that item is removed and put back in, the dimensions, its current dimensions are cached, stuck onto that item so that your layout doesn't get screwed up because the inner content of that item suddenly disappeared from you. So it makes it really easy to scroll around, scroll up and down and maintain position. The awesome thing about this approach is that to really get it performant, I had to do some detection to decide what had happened to the underlying array. So I can know if you've prepended to your array, and I can use request animation frame to very easily give you an infinite scroll in either direction. This is great for a conversation when you might land in the middle of it and you really don't know how much you need to load above or below. So I've got the little async image in here, and I'm just hitting the warm pixel API to pull an image as I scroll up and down. So this is great, but it's for scrollable divs. What I'm working on right now, and I've really just largely hacked this together in the last 24 hours. It's an idea I've been mulling for a while, but it doesn't directly apply to our actual application. It's just something that I really want to be in smoke and mirrors for the future. So I've not really been able to justify working on it outside of some free time. I want to take this concept of if you're a little bit off screen, set visibility to hidden. If you're a lot off screen, cache the dimensions and remove all the content, and apply it on a much larger scale. So if we were to have a really big list here. And I don't remember which version I'm on here. I'm swapping these out as we talk. Here we go. Let's start with the non-occluded version. All right. So what I have here is a list, and we are at, what's our rate at? 100 rows with 10 items each. So we're already at a lot of DOM elements here without really having gotten very fancy. Still, performance, if I decide to do an n by n, if I were to up that to 100 by 100, you would likely see your browser freeze and never render anything at all. So this simple case, we can still scroll fine, we still render fine, we're not trying to re-render anything. But if you were to, for instance, on this list, let's say each one of these items were a movie, and this were your Netflix homepage, and each one of those movie previews had lots of little extra DOM elements to say, hi, do you want to rate this movie? Do you want to watch this movie? You would very quickly get into a situation where any re-render, even your initial render, your DOM is slow, it's sluggish, you can't do anything you want to do in terms of animation. And very likely you end up with the dreaded, your browser's unresponsive screen. What we can do instead is occlude this in a lot of different ways. So to start, I'm just going to occlude every single item. Let's blow this up. I think that's a little small. All right. There we go. So all I've said here is iterate over, and when I get down to each row item, I'll put a viewport. Now what's interesting about this viewport component that I've thrown out here is the viewport component doesn't do anything special. It's a standard default Ember component with the occlusion mixin tossed onto it. The occlusion mixin, what it does is it says, go grab the occlusion service. I've extracted everything that I built into the smoke and mirrors occlusion collection into a service instead, which means that any component in your app can subscribe to this service and find out information about where it is on your page. So if you want to go and include a lot of items, you can. Now, this is really early code and it's very buggy, so I apologize for the different blank spots that are going to show up here, especially with as many items around this page. But what you'll see in the DOM, we pop this open, it's not even going to want to open. No, all right, it's working. There you go. Right now, as we get lower down, we get into visibility hidden. If we get really far down, you start seeing some dimensions. These are these slack ratios of how far off screen does something need to be before you hide it versus how far something is off screen before you completely remove it. They're adjustable. But we're not really gaining any performance benefit from this method of occlusion right now because there's literally only one DOM element inside of each one of these items that I'm occluding at the moment. So this comes down to, this is a choice on you, the developer. If you really want to go down this road for performance of removing items from the DOM in order to improve your render, you have to decide how to group those items. So common way of doing this with conversations is to group by page. So if you have a paginated API, it's a really great way of doing it. You say each API page result is one single block that you're going to include or reveal at a single point in time. In this case, we're going to call it by row. So we drop this off. You'll notice that this next body of code is different only in the sense that our grid item is no longer the component. We have a new row class that we've thrown in here, and the row class is now the component. Hide at, occlude at, these are adjustable. This is not the final API, this is my hack together API in this, but basically what this means is at what point do I want to go invisible? 2 just means when I'm two sections off the page. So you get both an X and a Y zone, is what I'm calling them. So if you're in the viewport currently, it's 0, 0, both X and Y. As you go off in one direction or the other, you're gonna get, if you're above it by a little bit, you're gonna get 1, and then finally you're gonna hit 2. It's done in terms of viewport sizes. So if you resize the viewport, these are gonna change. But it lets you kind of decide based on how far off some screen is, based on the actual medium size, what strategy you want to do. So hide at 2, occlude at 3, and doing this on a row instead. So again, it's unfortunately a little buggy in this first implementation, but we end up here in the DOM. Ooh, what did I get? Where'd I go? I think I just refreshed finally. That's probably what happened. Dude. Yeah, okay, rows now instead of items. We can watch the march as we go up and down. So the advantage of this is that if you did want to go down this huge DOM tree, you had this huge list. Instead of having included just a couple of items, you're now including entire rows. Or if you really wanted to go far with this, you would say, all right, these are entire folds. So you would just wrap an entire fold and say, this fold includes when it's 2 far off. This fold includes when it's 3 far off. And you want to do things in bulk. Including small items like this, it's not very performant. Including large areas is far more performant. But by extracting this into a service, instead of forcing you into a scrollable div or forcing you into a specific way of occluding in your body elements, which is what Ember cloaking does, is your body has to be this, the entire thing has to be scrollable in a certain way for it to work. It lets you just pick any item you want and say, this section, this area, I want to be able to remove this when it's off screen. So that's it for my talk for today. But anybody have questions on that? Yes?
So when you say hide at 2, and that number, is that like a multiple of the screen height, or what is that?
Correct. It's a multiple of the screen height. Well, it depends. It's a multiple of the screen height if you're occluding based on horizontal distance, or vertical distance, I'm sorry. But if it's based on horizontal distance, it's the screen width. It uses the same integer for either direction. Anybody else? Yes?
Do you recycle and reuse?
No. So the main reason for that is because being able to keep a div in the DOM that has the correct dimensions gives you a much more accurate scroll bar, and it has the advantage of, if you decide you want to go down the path of having better ARIA support, you have a natural DOM element that you can, if you need to, attach different ARIA labels to and go target. And since your scrolling will then reveal that when the user gets there, it enables you to still keep your ARIA support if that's really a concern to you.
So it's not removing anything, it's just hiding it. Yeah.
So it eventually does remove it, but it leaves an outer wrapper. So whatever you decide, like that your area that you want to occlude is, that area is going to have an outer wrapper, and you can use that outer wrapper for a lot of things.
Yeah, so, sorry, my question was the inner of the outer wrapper, do you reuse those? Or do you
No.
just re-render?
I've tried a lot of different strategies with reusing things on the inside of these items. Unfortunately, the create element hook in 110 behaved much differently than the create element hook in 111, and I just decided I was going to wait until the rehydration mechanism in fastboot before I really went down the road of seeing how much DOM recycling I could do. There's some really interesting possibilities out there with that, but it's
I've done a fun hack where we don't have this as a primitive, but we should add it as a primitive, where you can actually like pull a tree out, move it somewhere else, and then splice it back in afterwards. That might be an interesting way to. We need to add that. We need to actually formalize that API. That might be a great way to get performance.
Yeah.
Keep a pool of the things that have been removed and.
Exactly. Actually, that is another talk that that Eric Brand almost got me to tell today. I have this web workers add-on I'm working on, and the thing about that is my end goal with that is a root stack. I really want this idea of any route you've previously been in, its DOM is put into a document fragment. It's pushed into an iframe, which has its own memory context, but is still on your main thread. So you're taking it away from where you're currently at. You can transfer it back and forth, and you can hook it back up at any time. Additionally, with the fast boot work and the DOM-less Ember, if we were to throw that into a web worker, generate your DOM there, we could say, all right, I know that from this route I could hit these 10 other routes. You call out to the web worker, it gives you string DOM, you toss that into the iframe where it generates the document fragment and adds it to the root stack for you. So it gives you the same concept you get in mobile dev on iOS in JavaScript. You want to go peek ahead, you want to go say, all right, I'm on route A, I want to transition to route B, and I want to drag my finger and be able to see the next route right away, you'd be able to do that. So that's...
The peek ahead for dimension is super cool.
Yeah. There's a lot of possibilities that Ember is about to unlock, and I'm really just happy with where Ember's going right now. So, yes?
Have you tried to use a set instead of an array?
No, I have not. So, but really my arrays have looked like all sorts of different things. It's just, yeah. Yes?
I was curious, like, you did like a hidden thing first, and then you go to occlusion second.
Why?
Yeah, like, and
Scrolling fast?
it's just because
That's literally why. The reason I do it in 2 stages is there's a performance win for just going invisible, but you also want to balance that with if the user is scrolling fast, you want to show them something. And so by setting it to visibility hidden, you can quickly give them that content back instead of having to completely recreate it. There used to be another stage in this, which is in that 110 version, which is instead of calling right away, you would just simply pull the DOM off the tree and hold it and put it back in. And I don't know what changed, but something between 110 and 111 changed it where the bindings would break when you did that. In 110, I could pull an object off and hold on to it and insert it back in, and the bindings were still valid. In 111, I couldn't, and so I pulled that out.
so having hidden around the currently visible area buys you a little bit of time for
Yes,
the. Otherwise, you could have just used occlusion for everything.
correct. Did I just see it in our? No. All right. So.